What if the moon is actually a fragment of Earth sent flying into space? Imagine a day in the distant past, around 4.5 billion years ago. Earth was a young, fiery planet, teeming with volcanoes and bombarded by asteroids. Meanwhile, a Mars-sized object, known to astronomers as Theia, was wandering through space. Then came one of the most dramatic events in the solar system's history. A colossal collision that changed everything. The first moment, cosmic catastrophe. Theia, traveling at tens of kilometers per second, slammed into Earth at an angle. This wasn't just a crash, it was a cosmic apocalypse. The immense energy released by the impact melted the crust and mantle of both planets, ejecting billions of tons of molten rock into space. Picture Earth transforming into a fountain of lava for a brief moment. This isn't an exaggeration. Fragments of molten material flew outward, like sparks from a firework. These sparks would eventually become the moon. The first minutes, a satellite is born. The debris, composed of material from both Earth and Theia, formed a massive ring of rubble around the planet. It stretched thousands of kilometers and burned at blistering temperatures. This resembled Saturn's rings, but with one key difference. This ring would give rise to a new moon. Initially, the fragments spun chaotically in orbit, but physics soon took over. Gravity began pulling the pieces together. Small clumps formed, merging into larger ones until, at last, the moon began to take shape. Hundreds of years. The moon's fiery youth. The newborn moon was a molten sphere of magma. Imagine it as an ocean of lava, slowly cooling over time. Its surface started forming craters, not from asteroid impacts, but from volcanic eruptions that released its remaining energy. And what about Earth? It was also going through a turbulent phase. The impact tilted its axis, creating the seasons we know today. An atmosphere emerged, and water from comets began pooling into oceans. Millions of years. The dance of Earth and Moon. Initially, the moon was much closer to Earth. If you had looked up at it back then, it would have appeared as a massive orb dominating the sky. The tides it caused were so strong they flooded hundreds of kilometers inland. Over time, Earth's gravity slowed the moon's rotation, causing it to drift away gradually. This process is still happening. The moon moves about 3.8 centimeters farther from us each year. Don't worry, it will stay with us for billions more years. Why does it matter to us? Without that colossal collision, Earth might have been a very different planet. The moon stabilizes our axial tilt, preventing wild swings in climate. Without it, nights would be darker, tides weaker, and human history might have unfolded entirely differently. What's next? The moon continues its slow journey away from Earth, but it will remain bound by gravity forever. Perhaps, billions of years from now, other civilizations will study its craters and marvel at how a small fragment of a massive collision became the satellite that shaped Earth's destiny. So, next time you gaze at the moon, remember, it's more than just a satellite. It's a testament to a cosmic catastrophe that gave rise to harmony,